let's do some simplifying of algebraic equations for Lesson 8. And remember, we can only combine, which means we can only add and subtract like terms. Terms are separated by addition and subtraction, and like terms have the exact same identical variable. In other words, the unknown is the same. In example 1, we have negative 2x squared y plus 6xy. These cannot be combined because the variable x squared y and the variable xy are not the same. So these are what we call unlike terms, and this would be as simple as this expression gets. For number 2, we have ab squared minus 7ab squared. Now those variables are the same. ab squared is identical. So we can combine them. What you have to ask yourself is how many ab squared do we have? In the first term, we just have 1. If the coefficient is not listed, it is understood to be 1. So what you would say is 1ab squared minus 7. Well, 1 minus 7 would give you a negative 6. And the variable stays the same, so it's ab squares, negative 6ab squares. Let's look at number 3. I have c, which I know is a 1c, minus a 7c, plus 2c. Well, those are all the same variable, so we can combine them. We would say 1 minus 7 is really a negative 6c, plus 2c. And negative 6 plus 2 would give us a negative 4c. Example 4, I have different terms, but some of them are alike. The first one, 6g, is the same as this negative 3g. Now remember, when you're doing this, put the box or put the circle around the sign that's in front of the term because it stays with the term. 6 minus 3, of course, would be 3. So I have 3g. What do I have left? Well, I have a 5, a positive 5, and a negative 7. So I can say 5 minus 7 gives me negative 2. My answer is 3g minus 2. For number 5, I have 8h plus 13h plus 7h minus h, which is a minus of 1h, right? So I have 8 plus 13, which is going to give me 21, plus 7, which is going to be 28, minus 1, which would be 27. That's how many h I have, 27h. Be sure you write it down. If you don't trust to do it in your head, but if you can't, you write it down to be safe. What's left? Well, minus 6, or negative 6. So I bring that down, and my answer is 27h minus 6. Now, number 6 is a little tricky because it's decimals, but let's just figure out which terms are alike. Look at the variables. This is 0.4y, and then I have a plus a 1y. Here I'll put the 1 so I know it's there. I have a negative 2.6y. Well, let's get them together. 0.4y plus 1y is 1.4, isn't it? So I've got 1.4y. And then I'm going to say minus 2.6. Well, when I say minus 2.6, I really have to subtract, don't I? I'm going to subtract them, and I'm going to have to do this backwards. I'm going to go up the other way. I'm going to say 6 minus 4 is 2, and 2 minus 1 is 1. I really have 1.2, but I have a negative because the negative was the larger sign. How many y do I have? 1.2, negative 1.2y. What else do I have? I have a negative 6.7 and a negative 0.03. Well, those are both negatives, so I add them together. Add them together, 6.7 and 0.3. I would add them together. I ended up with 0, carry my 1, 7. A negative 7 is a whole number, isn't it? Minus 7, right? Be sure you check your signs. That's a very tricky problem and easy to make a mistake on. Example 7, I'm going to distribute this negative 4 inside parentheses. So I say negative 4 times y would give me a negative 4y. Remember, the coefficient of that y is a 1, isn't it? And negative 4 would also be multiplied times a positive 6 would make it negative 24. The answer is negative 4y minus 24. For 8, I say negative 2 times 4x would give me a negative 8x. Negative 2 times a negative 3z would be a positive 6z, and a negative 2 times negative 1 is going to be a positive 2. Now look, those are 3 terms that are not alike. They do not have the same variables, so they can't combine them. That's the simplest form of that. Number 9, I'm going to distribute multiplication twice. 4 times 2x will give me 8x. 4 times a negative 3, negative 12. For the next set, I'm going to say negative 2 times x, negative 2x, and negative 2 times 1, negative 2. Now I can combine my x terms. I have 8x minus 2x would give me 6x. And I can combine my number terms. Negative 12 minus 2 gives me a minus 14. Example 10 is tricky because it's words. We have to say subtract from, which means we translate backwards. The thing that goes first is going to be 12 plus x, and then we're going to subtract 4x minus 7. Putting them in parentheses is always the safest way. So let's write it down and see what it looks like. 12 plus x minus 4x minus 7. Now, I have a negative outside parentheses. I have to distribute that negative. It's like distributing a negative 1. So I can say 12 plus x in my first ones and get rid of the parentheses. Then I say negative 1 times 4x would give me a negative 4x. And the negative 1 times negative 7 is going to give me a positive 7. In other words, a negative outside parentheses basically changed the sign of everything inside there. I went from a positive 4x to a negative 4x. I went from a negative 7 to a positive 7. But now I have terms that I can combine. I have plus x minus 4x. Well, that's really plus 1x minus 4. 1 minus 4, negative 3x. And then I have 12 plus 7, which is a positive 19. The answer is negative 3x plus 19. Now, example 11 is what I would call a challenge problem. It's working with fractions. We're going to do everything that we know to do, and then we're going to keep on simplifying until we get it as simple a form as we can. When I'm working with fractions, I still have to distribute the multiplication the same as before. So what I'm going to do is I'm going to say 1/5 times 9y over 1 times 2 over 1. I'm just going to think of all of these whole numbers inside as fractions. I'll just put them over the number 1 so I don't forget. So when I say 1/5 times 9y over 1, I multiply numerators. 1 times 9y is 9y. 5 times 1 is 5. That's distributing the first fraction. Then I'm going to say 1/5 times 2 over 1. Once again, multiply numerators. 1 times 2. 5 times 1. And then I'm going to do the same thing with the second fraction distribution. I'm going to say, and remember I'm multiplying, remember the sign is in front, right? A positive 1/10 times the 2y. 1 times 2y gives me 2y. 10 times 1 gives me 10. And this positive 1/10 times a negative 1. Well, 1 times negative 1 is a negative 1. 10 times 1, 10. All right, now what can I do? Well, I don't have like terms. So my fractions that are fifths, I need to get those to tenths. Let's just do the conversion real quick. I'm going to multiply each of those, each term, each numerator, denominator by 2 to get them to become tenths. So what I in essence have is 9y times 2 would be 18y over 10, plus the next one would be 2 times 2 would be 4 over 10. And then the others are okay. Plus 2y over 10 and minus 1 over 10. I have a common denominator, so I can now write my fractions, I'm going to move over here, over that common denominator of 10. Everything else goes to the numerator. Well, everything else is 18y plus 4 plus 2y minus 1. Remember, the operations go in the numerator too. Can I combine like terms in that numerator? Well, I have 18y and positive 2y. That gives me 20y. Remember, it's in the numerator. 10 is still in the denominator. What about the numbers? I have a plus 4 and a minus 1. That would give me plus 3. And that is as simple as my numerator gets. It's over a denominator of 10. At first glance, it looks like we could reduce the 20 and the 10, but you have to stop and say the only way you can reduce fractions is if everything in the numerator is multiplied, and it's not. We have addition. So we cannot reduce when we have addition or subtraction as part of our fraction.